portals, L1 function calls, and that's essentially what we'll be taking a look at now, and a little on some contract stuff. So we're essentially starting out with some of the contract stuff. So for milestone 1, the Rollup contract is super simple, and as Mike also alluded to, it essentially have one job: make sure that this like state hash is on track, and that you only update it when there's a valid proof. So essentially you have this. Can you guys see my mouse?
Yeah.
Okay. So you have this transition function that's essentially taking some state and a block, and then you're getting this new state. And the thing that the circuits and this Rollup contract in combination is doing is enforcing this T function. Mostly the circuits, but essentially, as I pointed to before, a sequence will be throwing this large blob of data and a proof to the Rollup, and the Rollup would then decode this into some more meaningful data that we can pass into to the circuits. And yeah, then we will use like this contract verifier to check that the data we got from the block together with our current state gives us this like new state. And if the current state is not aligned or proof is invalid, the entire thing reverts and nothing essentially happened. So this is what it looks like at the moment logically. And just to show how simple it looks from the contract point of view here, it's essentially just like one function to execute the verifier, and then some decoding. For this first milestone, we only handle the transactions like inside Rollup for the first couple of milestones. So we don't need like anything to go across. There's really not much going on in this contract at all. It also means that we can pretty easily just make the contract fully immutable, and also in the future it will not, like, the Rollup itself will never hold funds. You will have these portals that instead are holding funds, which means that 90% of the code from Aztec Connect is just removed, and we have this one function left really. And sorry, Jan, on the naming, I will update it. So with that in mind, we can figure out like what is these portals and what do we actually use them for. So like a portal is really a way to make this cross-chain application. So in this case, it's like, say DAI is an application, and you want to have both DAI on like L1 and L2. Then this application is a way to communicate between the two layers. Because we want to say this is like the same thing on both layers. So when you are in layer 1 or in the layer 2 only, you are pretty free to communicate between different contracts. But when you want to move between these layers, we are limiting it to saying, hey, there's like one pair, so one L2 contract and one L1 contract, or L1 address really, that are like linked hard together. Practically, you could have it doesn't need to be an L1 contract. It could be an EOA, but that's a little weird in most cases. That would probably be a contract. And some of the questions that are often coming up when we like have mentioned this hard link is really like, why are we going with this link between this one-to-one link? EOA is an externally owned account, so that's like a user. So you could have that on the L1 side. It's essentially like a MetaMask that can mint funds inside Aztec with your special with your special USDC or whatever. Yeah, I hope that answered the question there. If someone can like raise their hands when there's a question, otherwise I might not notice it. But take a look here and there. So we're taking a look at why do we have this link, and there's a bit of reasoning on going to there. So really we are taking a look at like how do you order stuff inside blocks 101. So some of this was alluded to in Mike's talk as well. So really, when we are in the all public world, so in the world of Ethereum, when you want to send a transaction, you are essentially saying, hi, block producer, please execute this intent that I have specified in my public transaction. And you then have a bunch of these like intents ordered one after each other, and they can alter the same storage. And so you essentially have, if transaction 1 is altering a balance in this token A, then when we are reaching transaction 3 and it's reading from this new value. So everyone is like acting on this the current head of the state. And this works fine when you have one guy executes the entire thing. It gets a little weird when we have our private world, where you are essentially executing the things locally, then proving that you did it correctly. And then what you're passing on to the sequence is essentially, hey, I did something. Here is some outcomes from what I did. Please handle that. So you're getting into this case where, because you proved it at some point in time, you can only have taken into account the state at that point in time. So everything that you are reading is in the past. But when you're writing, you're essentially giving all of these like nullifiers and new commitments that you want the rollup to insert. This means that transaction 3 here can really depend on what happened in transaction 1 when they are both doing this private stuff. Or I can't like read directly from your thing because I didn't knew about it yet, which gives us some like weird gimmicks when we want to do some of this ordering. Essentially, it gives us this case where, because we have everything is happening in the past with our storage, you can't really put. And so normally in Arbitrum, whatever, you have in your storage set a value like this is the address that I will be receiving stuff from. If you're putting that into storage here, you could have updated it, and I will then make a proof where I use the old ownership and enforce this transaction. That's not really a good thing. So we can't use public storage really at all. In fact, everything executing inside Aztec, because of this weird flow with everything private happening in the past, you execute private functions and then you can go with public, and you can't really just jump back. So we can't have these like access control in public storage, which gives us a case of should we put it in private storage and tell everyone about it, which just end up in a case where it's ended up with every application having different ways to enforce this. So the easiest solution from our point was essentially, okay, we just enforce one-to-one, and then devs don't need to enforce this thing. If a dev want there to be like more input from L1, they can handle it in a L1 contract instead. So moving on from that, I hope it was not too confusing, maybe a little weird. Moving on from what the portals were, we need to figure out what is actually a message. Like messages, the stuff that we were passing between the layers, that we need to know what it is. Message is pretty simple. It's like some sender and a recipient, and then some message. Here it's like a message hash. In practice, we could also have linked it to just be like a specific message, a short message. The nice thing with just taking the hash is that we don't need to enforce a lot on how long can these messages be. We can essentially put it up on the developer to say, hey, I don't care what you're sending across, as long as I only like the bridge only needs to handle these small messages, then you can unpack it from a hash yourself. When we're dealing with L1 actors, we're here inserting like a chain ID. The main reason there was, as we alluded to earlier in Mike's talks actually, that if there's multiple chains that can all do stuff inside the Aztec, if you just have an address as the portal, you could have address collisions, essentially where someone on Polygon could could own your portal now, or could send messages as if he were the portal. So we need a chain ID there. The reason behind not needing a chain ID on the L2 actor is that all of our message parsing is handled through a contract on L1. And we can just enforce that only one rollup can read messages from there. So there's not possibility to send multiple places. Okay. So we know what the messages, we know what the portal is. Then we need to figure out how to send these messages between portal and something on L2. So essentially, we are using something we are calling a message box. So we have some sender. He can insert a message into this pending messages. At some point in time, the rollup will essentially move messages from this pending box into the ready box. So this happens atomically, just meaning that, hey, he can't just remove it from one side and not insert it into the ready. He needs to do both. And this needs to be enforced by a mix of the contract and the circuit. And then after this move, the recipient can consume this message. And consuming here meaning that you like spend this commitment. So this is like one directional, and you need one in the other direction as well to handle communication for back and forth. We have some specific changes that it's not as simple as just having two, mainly that our L1 and L2 don't really support the same functions as easily. So we end up in something that looks closer to this, where on L2 we're using append-only trees and nullifier set, and on L1 we're using a multi-set. So multi-set just means that, hey, you can insert the same message multiple times, and we need to like support this just to handle the case where, hey, I deposit 5 ETH and tomorrow I deposit 5 ETH again. We want that to be possible. And then we have something that's also a little maybe odd, because everything that's going on inside L2 only really happens in a transaction in L1. So when the rollup is executed, we don't like practically need to have this pending messages from L2 to L1. We can just insert them directly in this like ready messages on L1. So it just skips that one step. But overall, the flow here should be fairly simple to figure out. Any questions related to this before we move a little bit? Doesn't seem so. We have some issues though, and that's really fees and sequencers here. And this is not only the fees for executing stuff in L2. We have some issues with the communication here. So you can have a case where the portal is a DAI token deposit. So you perform this deposit into the portal with your funds are now locked in the portal. It adds a message into this pending messages box, but in doing so, it underpaid in fees, so the message is never moved to the L2. This gives a weird case where now the funds are just locked, so you need some way to handle these funds, or like either bump the fee, cancel the pending messages, and kind of need the portal layer to also handle that as well, which is a little tricky. Then we have something that's also a little weird, that we're doing like pulling. So normally you're having a case like this for anything that happens cross-chain, where you have a user, they move to this like message box, what we're calling message box ready. They perform a call there, and that is then performing a call to the contract. So if we look at the code here, they have some checks, don't really matter for us, and they're doing this target call with the message. This is fine when you're doing public to public stuff. It gets a little weird later on. So essentially, we initiate a message, the Rollup moves the message, and then to execute it, we have this full call data in the message, which in our case, where the call data could be related to private inputs, is just not something we can do. So we need to pull instead, which is giving us a flow like this, where the user would go to a contract, give it has like some inputs. The inputs don't really matter that much in this case, actually, as long as we can compute what message we need to consume from those inputs. And then the contract will go to this like message box, consume the message. This means that we could have a lot of private inputs, maybe a secret somewhere in there, and then we're just taking the Cody. I can see you raised a hand.
Yeah, sorry, I had to step away for about a minute. Maybe I missed this, but what are some concrete examples of messages?
So let's say that I deposit DAI, want to move DAI from L1 into L2. So message here could be the amount that you deposit in, and a hash of a secret that, like, if you know the secret, you can claim these funds on the other side.
Okay.
So
is there a distinction like with a transaction? Like this, a message is the same as like a description of a transaction of some kind?
It doesn't need to be a description of a transaction. It could be like a subset of data that's used in the transaction.
Okay.
So it just
Thanks.
Okay. So we can take this example actually with the DAI. So if you're just doing a plain deposit, you could specify, okay, I'm depositing like 500 DAI, or this is actually a withdrawal, but we could do the same thing the other direction. And then when we're doing it into the rollup, we would probably not specify who should it be to. We would specify a hash of some secret that, hey, if you know the secret, you can get these funds. It's not transactions for the polls, but it's information that the polls can use. So in the most poll, we have I have an example later that consumes some of it, but it's not directly a transaction. You can have a portal that also consumes multiple messages. It's essentially just a way to communicate between L1 and L2. And you could put really whatever you want in there. The reason it's not a transaction is just that you're not specifying all the call data. So you could see it as part of a transaction.
Yeah, it's like the almost the authorization for a transaction is the way I kind of think about it. If you look at the rollup in Aztec Connect example, what you would do to kind of model this in this flow is like all of the aggregate DeFi deposits to say Lido would be kind of messages on the kind of messaging queue, and they would be for one particular contract. That contract could incentivize someone to come along on L1, consume all those messages, invest the funds into Lido, and kind of then put messages back on the inbox to kind of update balances back on Aztec. So it's kind of like the ingredients for a transaction, but it's not actually doing the execution. That will be done by someone else.
Because I was kind of imagining that different like individual users would possibly be passing messages to each other. Is that a use case or no? That's
Not
what the
that
word
messages.
Okay. Yeah.
like you could do it, but it seems like a very expensive way to do it.
Yeah, right.
Thanks.
You may do it for a vote. Like that's the only thing I could think of. It's like your vote could be a message.
Yeah, you could essentially, if you want to do it like a vote, you could just consume all of them. Yeah, in one way. They don't really do anything. On the other, like on the other one, they just like communicate across. Joss.
So I just want to clarify my understanding. Somebody on our L2 invokes an action which they want to see have an effect on L1. What will happen is the pre-image to that action they want to perform goes into some public store?
Not the action. That was the thing. It's some like subset maybe of the action. You don't want the entire action, as then you're getting into this pushing case, which we have issues with if we're doing anything private. But you have part of it. Maybe I just let me just skip a little ahead. I have an example that shows it a bit easier. So this is what happens for like DAI deposit. Essentially, it's the same thing if you're doing the other direction. So you have a user that's like invoking this deposit function on DAI portal. The DAI portal will pull some funds from his account, and then it will send like a message to L2 message here. It was inbox and outbox. It was a little old, this one. I don't know. Maybe. Let me see how to zoom on this thing. Okay, zoomed out. One sec. Is this better? Okay. So this message is in the long. The message here could just be the amount and then the secret that someone, like the hash of the secret someone needs to know to consume it. A rollup will then be executed. This message is inserted into the L2 side of things, and you can perform this like consumption of the message, which would be that you go to the L2 DAI contract, and it consumes this message, and you now have 5 DAI or whatever you deposited. And the same thing if you're going the other direction. Did that help a little or still weird?
Is
I'm
this?
not-
Oh, sorry. Go.
No, you go ahead.
Is this separation like this pooling because it would create a link between the layer 2 address and the layer 1 address that is consuming it, or why is?
No, so say you're pulling, say you push a message, and if you're pushing a message, you would have essentially a target and the call data. Some of the stuff that is in the call data could be private information. So say
And you cannot avoid it.
You can kind of avoid it here. So say that you're doing a push where you're doing the deposit. Deposit is 500 DAI to Alvaro. This is not what you really maybe want to put on here. You would want just, hey, 500 DAI deposited to someone. And you can't do that directly if you're doing the push, as it would need some of the information like in this call data. But what you're doing with the pull is that you have the 500, and then you have, say, hash of your secret. Then what you do when you're getting to like the L2 side of things, so when you are over here, is that you say, hey, this is the account that I want to have the funds on. Here's the pre-image of that secret, and here's the amount. All of these could be private inputs to a private function. And from these, you could compute what is the message that should be consumed. So you have the amount, and okay, you have the pre-image. Those two together, okay, you know what message to consume. So now you consume the message. So now it's no longer public who received the funds on L2. which you would have if you're doing the pushing.
Yeah, I got it. Thank you.
But it's a little annoying as it makes our flow different from everyone else. Yeah. Is there more related to the Savio?
Yeah, would that create a friction in terms of user experience? Like, would the user have to also initiate a collect transaction on L2 in order to actually collect that DAI that he has deposited?
Yeah, but that's essentially the same thing you're doing now on Aztec Connect. So on Optimism and those, because you're pushing it in, you can forward some gas and you have all of the information to execute it. So that's fine to do. We can't really forward the gas as we don't have the entire thing yet.
Makes sense.
Yeah, you imagine an Aztec Connect transaction. You deposit to L1 and you send a transaction to L2. You can do the same things in parallel. They may settle 2 different times, but that's okay.
It's also possible to imagine service providers that could abstract this away. And if you're like, oh, I'm fine with one app, essentially knowing the app will know that I deposited DAI, but they can just do that pull on my behalf and then just send DAI to my account. So at the protocol level, right? That's right, Lasse?
Yeah. At the protocol level, you are saying, hey, essentially saying someone needs to execute this, but that someone could be not you. So you could set it up essentially saying, hey, I generate everything that someone needs, and then I put some server, please broadcast this when this thing had been included. Yeah.
So the pre-images to these message hashes, how are they shared? Are they going to go in call data, or do we need some other component for data availability?
All of the data is essentially which direction?
I guess L2 to L1.
Yeah, L2 to L1. This is some of the weirdness. It's probably not going directly into L1 call data, but communicated over just the peer-to-peer network, simply to make it cheaper. Most of you would have that it's the same guy initiating it that wanted to execute it. So you don't need to necessarily pay extra to share it with the entire world. Make sense?
Yep. Okay.
Got it. We have, because the design is a bit different, we need to have some standard that helps a bit along some of these issues, like error handling. This is actually pretty similar to if you were doing Optimism upstream. Because everything is happening async when you're doing it cross-chain, you have no clue if it's actually succeed or not when you're initiating it. You also have this issue with as mentioned earlier, if you underpay, so it's hanging these messages never executed. We essentially need to have portal devs handle these failure cases. So say you want to do a swap on Uniswap, but everything is going through as it should, but the price have just changed too much for your transaction to execute at the point in time where you're actually trying to execute it. And let's say that the price just never goes down again. You want some way to be able to okay, this thing is not executing as it's supposed to. Send something back to L2 that there was a failure. Please unlock my the funds that was locked in this transaction. Otherwise, you end up with people just having locked the funds forever, which is not ideal. A separate issue is what I just call designated caller. If we want to support having bundles of transactions or these messages going on across chains. So say the Uniswap is a case of this. You don't just want to you need to send some funds from L2, make this swap, get some funds back into L2. So you're doing 3 different calls really. You need some way to handle the ordering. If there's no ordering enforced by this, you could just like try to do the Uniswap call. Okay, no funds. Then try to withdraw afterwards. So now you're sitting in a case where, okay, nothing really happened as I wanted it to, but something was executed. But it's not the best case we want, or the case we want. So we need to be able to have a case where we're saying, I want to have only A be able to start the consumption of some message. If you could do that, you can have these Uniswap-like transactions where you enforce ordering through saying who should be able to call what. So you're essentially getting this case, which is a super tiny to look at here. But what's going on is essentially saying that the Uniswap portal contract is the one that needs to be initiating the DAI withdrawal and do a deposit of ETH. So here I'm swapping DAI to ETH. So there's like 3 interactions on both sides of the chasm. You're having the initial withdrawal, the swap, and the swap happening on L2. This kicks off all of these messages to L1, and then you're executing, starting with the Uniswap portal. The Uniswap portal will start by, okay, withdraw some DAI because we need something to actually perform this trade. After it had received the DAI, perform the trade. After that, make the deposit of wrapped ether into the Rollup to get the result back. And then at some point you can do this like wrapped ether deposit in the end. It's pretty annoying to deal with more complex stuff, which is probably also the reason that no one is really doing this across any of the other cross-chain stuff. Like people mainly move tokens or call one function. They seldom do these more complex things. But we kind of want to support them, but we can't support it directly at the protocol layer by doing this enforcement. So it needs to be something that it becomes a standard on the portal developers. And then I just had a small description of drawing of the Rollup contract when we're moving beyond milestone 1, just inserting some of these message boxes, like in there. Essentially, we'll be setting up this registry that is a contract that points to the other contracts. And this is also what allows us to do an upgrade in the future. If you have this upgrade mechanism, you can essentially just redefine like this contract is the new rollup, but it needs to be able to still consume the messages that were pending beforehand. So we need to be able to just swap the rollup, and we do that through this like registry. Like that's the main thing I have related to everything that's really message passing, at least across chains. So I think let's cut it here. Yes, some questions.
Yeah. Oh, on the kind of multi-step L1 flow, like you basically have a contract on L2 that you send some DAI on L2 to that you want to be spent on L1. Can you just run through again? I understand that ordering is important, but does that mean that in the messages that you will be constructing, like the...
Yeah, you specify like a caller. So say the message is 500 DAI withdrawn to the Uniswap portal, and this message needs to be like consumed by the Uniswap portal. So the Uniswap portal needs to be the one that calls the DAI portal to start this message. And by doing that, you're making sure that, hey, I can't just execute your thing for getting 500 DAI into the Uniswap portal and then perform some other action. Now it's...
How does an L1 contract tell another L1 contract to consume a message? It's like a defined interface. Is that what you mean by
it's
standards?
Essentially, you don't need to tell another. It's essentially that you're telling it indirectly by having on the DAI portal a withdraw function that is like taking some inputs. So you could use the message sender as like, where should the funds go, It's essentially taking a 2 and an amount, and then it's checking that the message is coming from like the specified, the designated caller. Where here the 2 would be Uniswap portal, the amount would be your 500 DAI, and the designated caller would be the Uniswap portal as well. But because this call is made from the Uniswap portal, okay, this is all fine. It consumes like this message and send the 500 DAI. And then it performs this, like the swap afterwards. And if the swaps fail, the entire thing is reverted. So the message was never consumed in that case.
So it constructs the message out of the arguments passed into it.
Yeah.
And then consume. Okay. Cool.
Yeah. It gives us a nice way to have stuff that's very close to like exiting a normal DeFi position when you're actually exiting the rollup. Yeah.
Lasse, have you thought about how like an NFT integration would look through the portal contracts, like with OpenSea potentially?
So just like depositing an NFT directly, or you're thinking about like buying an NFT directly from the rollup, right?
Yeah, doing essentially all the things where like you can buy NFTs anonymously, you could do some listing of NFTs through L1,
So
things like that.
It's pretty close actually to this DAI case. So say that you have, instead of DAI, you have generic NFT one, where there's this like portal contract set up. So you have that they also exist on L2. You kind of need them to exist on both places to make it work well. So you can then have a transaction from L2 that is doing first a DAI, or people mostly buy NFTs with ETH directly, right? So you would have a withdraw from the rollup in ETH to this like OpenSea sales or buy portal, and then you have a call that is directly to this OpenSea portal for where you're passing it like, okay, I want to buy this NFT. This was the price, and probably who should receive it on the L2 when you're sending it back. So again, this idea with, hey, I'm sending this hash of some secret along. And then you have a flow that's very close to this thing, when everything that's saying DAI, that would be with, and stuff that was wrapped ether here would be NFT instead. So the flow is similar in these two cases. And then some of the nicer things compared to Aztec Connect is that you're not limited to like 64 bits of custom data. You could pass in a lot. So you could have that you buy like 10 different NFTs and get them all deposited. And for some of these NFT collections, or I know OpenSea have or what is it? Artworks. Some of these have multiple collections essentially on the same contract address. But you could also have one portal that is for a lot of different NFT contracts. And then you're just saying, hey, this is the NFT portal. So you don't have to deal with 10 different contracts for having these 10 NFTs, just deal with this one.
Okay, awesome.
So it should make that part a lot easier.
Yeah.
It's still annoying when you have to go through a lot of these things, but it's not like the end of the world to set it up. So I would guess someone specifically for NFTs, you would probably end up having a separate market over on the L2 as well. But if you're doing like very large deposits into something on L1, this could be something that's meaningful. Or simply to control a multisig on L1, something like that from L2. You could essentially have your entire position sitting on L1 and just have the access control from L2. Then you have the whatever saves normally doing with, hey, you can only move 10% of your balance, whatever. So you're just using the L2 as normal, like normal management. And then if shit hits the fan, you you can go to L1 directly.
Nice.
We will not support aggregation batching directly. Someone could do it, but it's not like natively part of this thing. But yeah, you could end up with sequencers that essentially do some of that themselves, or just like applications that you could essentially have CK Money as an application that don't run a sequencer at all. They just collect a lot, and then they build one of these large like messages or message with a lot of funds.
Yeah, I did some thinking on this as well. Like there's networks like Gelato or Chainlink have keepers. So you could set up a portal contract that has a keeper function on it. Effectively, a keeper is just, there's a function you can call where you get paid a certain amount of fees to perform like a piece of work. So that work could be check the message queue, see if a batch is ready. If a batch is ready, fire off the batch for a given kind of DeFi protocol. So it'd be quite easy to build batching functionality, but using other people or other systems which send the actual transaction.
So
would it be the
being the sequencer?
So would it be the case that in the message box there would be like multiple individual messages which would kind of like represent the same action, and then we would have like this
not
keeper
exactly
entry?
like that. You would essentially have before that step that you say you have storage on, like you emit stuff as events just on L2 or as data on L2 where you're collecting, hey, these 10 guys want to all into the same thing. Then when you're collected on L2, you can set one message to L1 really. So similar to how Björn is doing on L1, you just have that the coordination part is happening on L2.
You could do it on L1 as well, though, right? It would just be more expensive.
Yeah, it's just expensive.
Yeah. But you're basically trusting the logic of the portal contract. So the portal contract would have to say, wait till I have 15 messages. When I have 15 messages, I will execute the function.
Yeah, it's just when you add that step, you could just as well do it from the L2 logic and then only fire when ready.
Yep.
Adam, you had a...
Yeah, I was just wondering if, generally we're assuming that the common L1 protocols would get L2 wrappers, or are we expecting the user experience to be good enough just calling L1 directly? Or like, is there, or do we expect like, I guess, yeah, so there's a common Uniswap wrapper and it makes more sense for everyone to use that, or...
Yeah, and especially for some of the tokens, we need to make it really easy to make a very like generic token bridge, so that we end up with just one token bridge really, or one canonical version, so that we don't have 10 different versions. For many of the DeFi protocols, it might not matter the same. Not if you using them as like SAPs. So if they are stateless, it doesn't matter that much if there's multiple of them. If they have LP position, stuff like that, yeah, you want it to just be one that is essentially used to not make the liquidity super fragmented.
Got it. Yep.
Hope it was not too confusing. Some of it was.
My question would be like, are we going to have a different enshrined token? Like, for example, ETH is going to have like this canonical portal made from us, or is going to have a specific logic in the rollup contract or something like that?
So the Rollup contract will never handle any funds. Really, everything will essentially be through these portals. I think we will probably propose a way to do token bridging. But we would prefer if it's not us that like actually deploy or set up any of these.
Yeah.
So it just like the nice thing is that we could build a way to do it where you are very close to trustless or like fully trustless. You only have the same assumptions as doing stuff inside the rollup, and we could just set up a page where like, okay, this is how you can deploy it. That's essentially what Arbitrum at least did, then anyone can go to, like, they have a website, it deploys these things. And so if there's a token that, hey, if you want to have this token on L2, you can just go there and do it yourself. You don't need to like be super technical to figure it out. The thing we're moving more to doing stuff like that.
Okay, thanks.
And the registration of portals will be done the same way we did registration of bridges in Aztec Connect, that is like through the Rollup contract, or
It
how
will
will it
essentially
work?
be done. We're still figuring exactly out the linking, but if you remember from earlier, Mike's slide, you have this contract leaves where you had the portal address and the contract address on L2. So we need to have some kind of handshake when you're linking them, and you could be linking them when you're deploying on L2. So you don't need anything to happen on the Rollup contract. Because, like, also you don't need the same issues we had with like gas, because the Rollup is not performing the calls. The Rollup is just inserting these messages, and then someone else needs to perform the calls. So you don't have this DOS vector, or DOS vector as we had in Aztec Connect.
Josh, do you want to go first? You got your hand up.
Sure. I guess that continues on the point about the link between the L1 and L2 contract. How flexible is this relationship in terms of upgradability? Can a portal start pointing at a different L2 address, or
no? If you want upgradability, not as we have designed right now, at least, if you want upgradability, you could essentially, if you have an upgradable L1 contract, upgradable L2 contract, then you can just upgrade those. The points are the same. The other thing is, like, if you want to do like full upgrades and you have immutable contracts, then it's essentially a migration, and then it's two new things. You could also have that your L1 portal contract is essentially just like a relayer. It doesn't hold any logic. Really, but it's just like forwarding messages to some other contract you have on L1, so that you can easily swap that out.
Okay, so I guess the bigger question is what upgradability looks like within L2.
Yeah, like my showcase delegate calls, or it wasn't the list earlier. So if you have delegate calls, you can make proxies, and then you can change the logic in your contracts essentially. Yeah, then our upgrade would be similar to what's going on when we upgrade Aztec Connect, where the address and all the storage stays the same, but like the rules of the contract change.
Is there any information on how many messages we can cope with, both on the L1 or the L2 side? I presume it's unlimited on L2 side, but
like insert, or like are you talking about how much we can move along?
yeah,
So,
both in terms of message size plus total count.
yeah, so like because the messages were very close to just being the hash, and a little over, the cost is essentially constant there. And nice thing is that when you're inserting from L1, the insertion is pretty expensive, but it's not the rollup that performs that for like incoming transactions. So you need to flip like 1 bit when you're consuming those. So that can be pretty cheap. It's a bit more expensive when we need to like update a storage slot when we insert a message from L2 to L1. But it's still pretty cheap. So we are essentially at like 20K and a bit for inserting messages. So you could have a high limits, is that we are not like strictly saying what it is, but it must be up to the sequencer then to include how many you actually want to. And it also changed a little if there's a lot of duplicate messages, they will essentially land in the same storage slot, just incrementing a counter. So if there's a lot of like deposits, 10 ETH to something, like 10 ETH deposits to Curve, whatever. You could have a case where, okay, all of these can almost be consumed for like 15K. But if there's a lot of very different messages, okay, we need to like update a new storage slot every time. So it should be pretty cheap to move them across. Okay. Any other questions?
Awesome. Thanks, Lasse.